this video, we're going to look at how we can use a Venn diagram to organize some information. There's some sets that we have here, and also, of course, allow us to determine some probabilities involving those sets. Now remember, we are really dealing with events, A and B, and our sample space is our universal set. And the outcomes in each of those events can be thought of as sets. And if we start counting the number of outcomes in each set, that's something called the cardinality, and that's, of course, what's listed here. So we're given the cardinalities. Number of outcomes in our universal set is 72. That just means there's 72 things or items in our sample space, or our universal set here. And in the number of outcomes in one of those events, A, is 40, and the number of outcomes in a second event, B, is 35, and the number of events in the intersection of A and B is 15. Draw a Venn diagram to represent this situation, and trust me, that'll be the hard part. As once we have that, we can just make sure we know how many items are in our sample space, and of course we know 72 outcomes, I should say, are in our sample space, and then we can use our Venn diagram to calculate those four probabilities listed there. So how do we put together a Venn diagram? Well, hopefully you recognize that the U is the sample space, and A and B are your two events that you're trying to keep track of, at least the number of outcomes in those events. So we need two circles, and we're going to label them A and B. And first and foremost, with any Venn diagram, if you know your overlap, that's a very good situation, and it's typically not difficult to complete the rest of your Venn diagram. And lo and behold, we know that there should be 15 outcomes that are common to both event A and B, or the intersection of A and B is 15. So once we know 15 goes in the overlap of our circle, we can then use our, circle totals. And remember, these are the number of outcomes in event A and event B, respectively. So if I know there's 40 outcomes supposed to be in that event A, then of course I can simply subtract 15 from 40 is all that's saying. And remember, this is the A only section of your Venn diagram. You can use that backslash or different set notation, but I chose just to say the number of outcomes that's in A and not B is going to be the number of outcomes in A minus 15, 40 minus 15, or 25. And if that's not clear where I am in the Venn diagram, then yes, I'm in the A only part of the Venn diagram. And note, if you add 25 and 15 together, you get 40, which tells me we're on the right track. We have at least the total number of outcomes in event A correct as of now. And then we do a similar thing for the B only section, which remember is B and not A. It's going to be the number of outcomes in B, again, minus that overlap. So now 35 minus 15, or 20, in the B only section of our Venn diagram. And if we total those numbers up, we will get 40 plus 20, which is 60. So that means we're missing 12 in our sample space. So again, that is the number of outcomes that aren't in the union or aren't in the two circles there, in any part of those two circles. Of course, that'll be the number of outcomes in our universal set or sample space minus any of those numbers that are inside your circles, or just 72 minus 60, which is 12. And now we have our Venn diagram complete, and now we can move on to calculating our probabilities. So hence, determine the probabilities. The probability of A. Well, if you know how many outcomes are in A, you're going to divide that by the number of outcomes in your sample space. So of course, your Venn diagram sitting in front of you there, you would just say, in my A circle, there's 25 plus 15 outcomes. So that means the probability of A is going to be 25 plus 15, or 40, divided by the number of outcomes in the sample space, which remember is the cardinality of your big U there, your universal set. And that's, our little Roman numeral 1 finished. And number 2, find the probability that of not B. So of course you look at your Venn diagram and you make sure you count up any number that's not in the B circle. So the probability of not B is going to be the yellow 25 and the pinkish number 12, again divided by the number of outcomes in your sample space. So that probability is 37 out of 72. And now for number 3, the probability of the overlap or the intersection of A and B. Of course, that's going to be 15 in the overlap of the two circles, again divided by 72. And incidentally, I'm not reducing any of these fractions, just so we can see that they're all out of 72. But if you want to go an extra step and reduce some of those fractions, like numbers 1 and 3 there, go for it. That is completely acceptable. And then lastly, the probability that we're not in the union. So that's not A or B. So when I read that, I say, okay, probability that I'm not in any of those circles in any region of those, I guess, 3 regions of the circles. So of course we're looking for our pink number at this point. So the probability of not A or B, or not the union, I guess I should say a little more correctly, is going to be 12 out of 72. Okay, and one more example in this video. We'll examine a group of 70 students where 46 play computer games and 25 of these students play board games, and we know that 6 play neither. We'll construct a Venn diagram to represent this situation and information, and then if a student is selected at random, find the probability that the student plays both computer games and board games. So hopefully the word "and" there makes it clear to you that you're actually looking for the overlap in your Venn diagram, the intersection. So before we get to a Venn, let's be clear that we have 2 events. It doesn't matter what you label them, but I'll just go with kind of the industry standard A and B. And event A is going to be the event that a student plays a computer game. So I'll just say computer game. And event B, of course, is the event that a student plays a board game. So of course, if we think about that, I'm sure we can find a student that plays both computer games and board games. And with the given information here, hopefully we find such students, because that's the probability that we're looking for in part B. So let's look at a Venn diagram here. And notice I'm still just writing the cardinality of each set in here, where the numbers that go in here, of course, don't represent probabilities. They represent the number of elements in each set, each subset of this universal set. And at some point we'll make the transition to actually just writing down fractions or decimals, the probabilities in each section of the Venn diagram. But I think for this video we'll stick to what we're more familiar with. So notice Venn diagrams are easy if you know the overlap, and I'm sure you've recognized up until now, since part B is asking for the overlap, and it's not immediately clear that we have the overlap because all we know is the total. 46 is the total that's in our A circle, and 25 is the total that's in our B circle, and we know that 6 play neither, so at least there's one step in the right direction. I'm going to put 6 people out here, because we know 6 don't play any computer games or board games. Just hard to believe, I know, but anyway, it's the information in the question. So that means in our circles, we would have to have a total of not 70 anymore. Since 6 are outside of our circles, we need 64 people in our circles in the union. So I'll just say, I guess, A or B. If you want to use the union symbol, extra points, I guess. So we have 64 in our circles there, 70 minus the neither, folks, the 6 that are outside of our circle. So of course, if we add those totals together, recognize that if I add 46 and 25, that should be the totals in at least the individual totals in the circle. And if we sum those up, now I'm not using any formulas here. I'm going to do this, I think, just exercising some common sense and reasoning. If we add these up, we'll see that we get 11 and 60, which is 71. And if I'm only supposed to have 64, well, how is this possible? Well, the difference between 71 and 64 is actually your overlap. So if we subtract 64 from the, I guess, the two subtotals of our circles, we'll realize that we have 7 extra, which have to go in the overlap. So it's kind of the way I prefer to find the overlap in a 2-circle Venn diagram, but just to be clear that if you see somebody using our, remember the inclusion-exclusion principle, that is still an option, but I find it makes this much more abstract and maybe a little more difficult, which I'm not sure is really necessary, but let's just get used to that again, that if we're going to keep track of the number of, number of elements in each of these subsets, remember, there's still the number of outcomes in each of these events. So I'll just say the number of things in our union would be the number of elements in set A plus the number of elements in set B, and don't forget to subtract away the overlap, which of course is our intersection, which we just used some basic reasoning there to figure out that this is 7. Well, if we first clue in that out of the 70, 6 aren't in our circles anymore, then of course our union is now going to be 64. 70 minus 6, maybe I'll write that out. So we'll go 70 minus the 6, just to show you why our reasoning works. So I guess not why it works, how our reasoning can be written down using set notation if you're interested. So how many elements or outcomes, I should say, are in this event A, or how many elements are in this set A? Same thing, that should be 46. And notice we're going to add that to the number of elements, to the number of outcomes in event B here, which is 25. And then we realize we're looking for the number of outcomes in our overlap, which is this unknown right here, which if you want to call it an X instead of using that cardinality notation there, go for it. So this means 64 must be equal to, guess what, same number we figured out before without using all this set notation. That's going to be 71. And we have that subtraction there, which is actually good news, because if I do some rearranging now, we won't get a negative answer. And if you get a negative answer for the cardinality of a set, you definitely messed up something. So let's add that number of outcomes to our overlap to both sides, or I'll relocate that to the left, and I'll subtract 64 from either side. And of course that tells us that the number of outcomes using our principle of inclusion and exclusion is going to be 71 minus 64, which is 7. So remember, that's probably not necessary for a 2-circle diagram, but I just want to show you that if you see that in an answer key, you can just either ignore it as long as you get the correct answer, but keep in mind if it was a 3-circle Venn diagram, you would have to most likely use your principle of inclusion and exclusion, which is what we've just used here, of course, for this 2-circle Venn. So once we have all of that, let's finish off our Venn diagram. And I realize I actually don't even have to, because for part B, all we're interested in is if we select a student at random, find the probability that the student plays both computer games and board games. So let's get rid of this fun stuff here, and we can actually just answer part B. But for the practice, I will still fill out the rest of this Venn diagram here, I guess practice for you. But you realize if you have your overlap, then we can just go ahead and convert this to a probability. I'm going to say the probability of A and B is going to be the overlap, the number, of course, outcomes that are in our overlap, which is A and B, which is, I guess, a pink 7. And we'll divide that by the number of outcomes that are in our sample space, which of course is 70. And that's all we need. There's our answer. And if you want to write that as 1/10, that works as well. So there's a 10% chance that if you pick a student at random, that they'll play board games and computer games. And again, just for the practice, let's fill in the rest of our Venn diagram here, where if I have 46 in my A set here, or in my number of outcomes for event A, I have to subtract 7 from 46. And I'll just do that in white. So that's going to be 39. And double check, 39 plus 7 gives me 46. And then take 7 away from 25, which is going to give us 18. So notice I didn't need those numbers to determine any probabilities in this question, simply because we weren't asked for any probabilities that involve the A only section of our Venn and the B only section of our Venn. But at least it'll help you understand that if you got your correct overlap, if you add all these numbers up, of course, you will get 70. And I guess we can check that one last time, because right now we got 46, and I got 18 and 6, which is 24. And if I add those together, check, we get our number of outcomes in our sample space, which is 70. So there's, again, maybe a little more basic, easier to understand Venn diagram question, because at least the numbers have some meaning to you on paper, as opposed to the first example that was simply just listing cardinalities and without any meaning. But now we have a little bit of meaning, and notice that once you get the number that you are interested in for part B, there was really no need to fill in the rest of this Venn, but of course just did that for some practice as well, because I'm sure in future videos and some other practice problems you'll be asked to probably use other numbers than just the overlap in your Venn diagram.